Lesson 11. How do I solve proportion problems using factor puzzles? So we're going to be looking at proportion problems again, and we're going to be solving them mainly with factor puzzles, not ratio tables. Now we are going to skip around a little bit. We're actually going to look at workbook page 30. If you look at workbook page 30, it gives you a couple different proportion problems. We have proportion problem 1, proportion problem 2, and proportion problem 3. We're going to read through each one, and we're going to see how they set up their factor puzzles. Proportion problem 1. Anne planted 35 rose bushes, while Jim planted 14. When Anne had planted 15 rose bushes, how many had Jim planted? So you can see that they used the labels of Anne and Jim at the top. Anne came first, Jim came second, so we have 35 to 14. And then the 15 rose bushes went underneath Anne. And then we were able to solve the factor puzzle and see that Jim would have planted 6 rose bushes. So that's the very first proportion problem. Let's take a look at proportion problem 2. Proportion problem 2. Jim planted 14 rose bushes. So here's Jim. Here's his 14 rose bushes. While Anne planted 35. So here's Anne and here's her 35. How many rose bushes had Jim planted when Anne had planted 15? So this 15 is going to go underneath Anne. And when we solve it, you can see that Jim would have planted 6 rose bushes when Anne had planted 15. Let's take a look at proportion problem 3. When Anne plants 15 rose bushes, so here's Anne and here's the 15 rose bushes underneath, how many does Jim plant? So this was where our missing number would have been. Anne plants 35 rose bushes, so 35 must go underneath Anne, while Jim plants 14, so the 14 had to go underneath Jim. And 6 is the amount of rose bushes that Jim would have planted when Anne plants 15. Do you notice any similarities? Hopefully you notice that all 3 of these proportion problems are actually all the same proportion problem. Every time you're trying to figure out how many rose bushes Jim plants when Anne plants 15. The only thing that changed was the way they worded it. They changed the order of it. In proportion problem 1, they said Anne first and Jim second. And then if you look at the factor puzzle, we have Anne first and Jim second in the labels. But the numbers are still in the right spots, right? 35 was still underneath Anne, 14 was underneath Jim, 15 was underneath Anne. In proportion problem 2, Jim was mentioned first and Anne was mentioned second. And so that's what it looks like in our labels, Jim first and second. But again, you have the 14 underneath Jim, 35 underneath Anne, 15 underneath Anne, and again, the missing number went underneath for Jim. Proportion problem 3, same exact thing. They mention Anne first, Jim second, and they do it in a little bit different order where they kind of ask you the question first and then they give you other information later. Every single problem is exactly the same. All they did was change the order. The point is, there are multiple ways that you can set up your factor puzzle. It does not have to be set up the exact same way every time. What you need to make sure that you do is to make sure that you use labels. Labels are going to help to make sure that you do have numbers going in the right spot. You wouldn't want this 35 here to be underneath, Jim. You want to make sure it goes underneath Anne. That's the point of the labels. Yeah, there's multiple ways to solve this proportion problem, but there's also a couple ways to do it incorrectly as well. Use labels to help you to make sure that you put everything in the correct spot. Also, I know they tell you it's a proportion problem. I mean, it's pretty obvious, but you are actually making some assumptions here. In order for it to be a proportion, you're assuming that you have ratios that are the same. You are assuming that in each of these problems, Anne and Jim are planting rose bushes for the same amount of time. So maybe they're planting, in an hour. Maybe Anne can plant 35 rose bushes in an hour and Jim can plant 14. Maybe this is over the course of a day. Maybe Anne can plant 35 rose bushes in a day while Jim plants 14 in a day. We're assuming that it's happening for the same amount of time. It wouldn't be fair to compare Anne and Jim if we're talking about different amounts of time. We're also assuming that they each have their own constant rates. We are assuming that the amount of rose bushes that Anne plants is going to be the same no matter what the amount of time is. That she's going to plant the same amount of rose bushes every hour or the same amount of rose bushes every day. And the same thing for Jim. We're assuming that the rates that they plant their rose bushes are constant. Otherwise, you wouldn't have equivalent ratios. You wouldn't have a proportion problem. So, that brings us back to workbook page 29. We're just going to look at number 1. Write the assumptions that must be stated to make the problem a proportion problem. Make and label a factor puzzle for the problem. Box the unknown and solve the puzzle and the problem. So let's look at number 1. 2 bands march in rows onto the football field. When band A has 15 people on the field, band B has 6. When band B has 14 people on the field, how many people will band A have on the field? So it sounds like we're talking about band A. I'll do BA for band A and BB for band B. And let's see, I have some assumptions here. I'm assuming that this is a proportion problem. I'm assuming it's a proportion problem because I would think each band continues to add rows on the field at the same, I should say, at their own constant rates. Okay, so I'm assuming that we have a constant rate. Band A is continually putting the same amount of people on the field. Band B is continually putting the same amount of people on the field. Alright, so we've got our labels. Now it's time to solve our factor puzzle. Let's see, when band A has 15 people on the field, so I'll put 15 underneath band A. Band B has 6 people, so I'll put 6 underneath band B. When band B has 14 people, so I have to put the 14 underneath band B. How many people will band A have on the field? So I'm going to be looking for the unknown. Let's solve this factor puzzle and see if I can figure out how many people band A will have on the field when band B has 14. So let's see, 15 and 6, they have a common factor of 3. 3 times 5 is what gives me 15. 2 times 3 is what gives me 6. 2 times 7 gives me 14, meaning the missing number must be 35. So when band A has 35 people on the field, band B would have that 14. Okay, takeaways. The main idea here, a factor puzzle can be set up different ways. It's important that you use labels to help make sure that each number goes in the right location.